How many of you guys have been to Defcon before? How many of you guys have done the car hacking village capture the flag competition? None. Perfect audience then. All right. All right. So this is about donkey cars and Defcon 26 Mad Max Challenge. Yeah, we all trust this guy. I'm David Owens. I run the Salt Lake City meetup for donkey cars, DIY robocars of all kinds. I'm at Distracted Dave on Twitter. Shameless plug, tomorrow there's a job fair. Come see me. If you're a good, solid Linux engineer, we're always hiring. I work at Expert Voice. We do outdoor and other type of marketing, and it's a great place. Oh. All right, Car Hacking Village. Now, DEF CON has a lot of different villages, as some of you are aware. There's lockpicking villages, wireless hacking village. Car hacking village is one that I've been hanging around recently. And there's a lot of different aspects. I'm in the Donkey Car Challenge, and we had a Mad Max Challenge. And so here's our track before we got started. There's two main challenges that we were doing. There's a RoboCar challenge, where they take an RC car, and they have a Raspberry Pi, and they actually have a custom board with a Grand Cherokee CAN bus right on it. And so you can wirelessly get on the Raspberry Pi and set commands. And then the Donkey Car Challenge is the second one. And it's built on a race in a donkey car head-to-head with another team. These are some of the other guys that I did it with. Sean there and Greg. Sean's on the left. There's the Spider there that is fully a donkey car, but spider-based. So that's a really cool little toy. And then the other one there on the left is the RoboCar. And you'll see it has a LiDAR out there on top, but it's actually not incorporated. It's just got a CAN bus straight up to the steering and throttle commands. So it's just like you would take it if you were to hack your own Jeep. So for the RoboCar challenges, they were part of the main Capture the Flag challenge that the Car Hacking Village was doing. And the way it worked is it was kind of a progressive challenge, kind of Jeopardy style. And first you had to hack the console. You can see here a picture of the console, and intercept CAN bus traffic. Once you could intercept that traffic, you needed to inspect it and dissect it and separate the different parts. You know, this unlocked the door, this turned the steering wheel, and figure out what everything did. Step 3 was reassemble and replay that traffic. So if you notice, it's much like a lot of different things we do in the network world. And then 4, once you can actually reassemble and replay that traffic, you could come grab one of our robocars and you use CAN bus traffic to navigate around our track. And so here was the track when it was fully done. As you can see in the bottom left, actually bottom center, you've got the start. You go down and do a U-turn up and over the tabletop, another U-turn into the tunnel, and a really tight U-turn coming out the end, and you had to maintain that park position for a minute. So in the RoboCar challenge, you were just using CAN bus, you just had to complete the challenge to get the points. In the head-to-head, the rules, don't get kicked out of this flamingo. So they're pretty open. As long as you didn't use fire or other things, you could do what you wanted. Navigate the course, park in the yellow square at the end, and hold it for 60 seconds. So it was offensive and defensive. So we had slow vehicles, we had fast vehicles, and there's different strategies they could go. Points were reduced if you hit cones, walls, or if you needed professional help or pilot intervention. So here again is the track. It's the same track for both events. I had a video here, but it's actually not working on the network of the two winners going head-to-head. It was very interesting because by this time, they've done the training, they've practiced, and now they're going to the head-to-head race, and their batteries are completely drained, and so they can barely go around the track, so it was quite funny. So before I go on to Donkey Car specific, I want to answer any questions about the Car Hacking Village specifically. There's a lot of other things there. There's scooter hacking, there's CAN bus hacking, there's full-size simulators, so you can actually drive around full-size Dodge on a simulator track. A lot of fun stuff going on there. But is there any questions on that side? All right, one question. Who's got the question? Anybody? No. All right. Okay, so Donkey Car, it started about 2 years ago in the San Francisco Bay Area. Will Roscoe is the person who started it. He ran for the Bay Area Transit Commission, the planning commission there. His platform was that he was going to replace all the trains in the Bay Area Transit and pave the landing that they were a part of, and then put self-driving vans and self-driving buses on that same lanes and dedicate it to only self-driving vehicles. And so you wouldn't have the people versus self-driving car problems that you have a lot of the times. And everybody pretty much told him that he was insane, that he was crazy, and that in 20 years we could never get the technology to that point. Will said, well, honestly, the Tesla technology is already to that point. Like, I know we can get there. We just need to get people aware of the situation. And so he teamed up with Chris Anderson, who used to be the editor of Wired magazine, and then went on to start DIY drones and 3DR robotics. And the two of them started the donkey car community. And it's pretty simple. It's just a Python code. It's a loop. There's 4 modes. There's a drive mode, a train mode, a drive with auto steer, and full auto, which is steering and throttle. In the basic loop, it just takes a picture and it records the inputs in a JSON file. It then checks the PI pins for receiver input from whether it's the web interface or PlayStation Remote or whatever you're using, and it forwards those to the PWM board. You're welcome to come up and take a look at the cars themselves. Almost any car will work. If you have a 3-wire speed control and a 3-wire servo steering, you can make it work. We use a $10 PWM board just to offload that from the Pi. You could actually do some of that on the Pi. So before we go any further, I want to kind of go into a few definitions. These words get thrown around, and a lot of times they're used in the same time. But artificial intelligence, this just means that a computer that is as good as or better than human, it's doing a specific task. So it could be something very simple all the way up to full Terminator and C-3PO. Machine learning, it's a method for achieving AI. It means making a prediction about something based on training from sets of parsed data. There's lots of different ways machine learning can implement training sets to predict things. Neural networks. Neural networks is one of the ways machine learning model can predict things. It kind of works like your brain by tuning itself through lots and lots of training. Lots of good data, lots of bad data, classification of data, and then essentially overlays those all on top, creates lots of different layers, and then congeals those together and gets you a prediction algorithm. Here's a few more. TensorFlow, it's one of the many machine learning softwares. Keras, it's machine learning software that helps you create models. Overfitting, having too much similar data. Essentially what will happen is it'll start ignoring things and just focusing on one thing. So for example, if you saw that video I was playing at the very first, overfitting might be it only sees the cones and it doesn't see the lines because it's seen the cones so many times. So you want to make sure to get lots of differentiated data so that it can then isolate the data that's important. Cleaning, just removing unwanted training data. So here's the flow of your donkey cars. First, you install and calibrate your car, and also install your workstation software. Then you gather the training data. Usually you would do that driving the car around, or if you're using the simulator, you could drive the simulator around the track. The next step is to clean that training data, removing anything you don't want, like it driving into a wall. Then you build the model, and then you use the model. So I'll go through these each. Installing the software on the PC, there's a very easy, well-documented, I don't know what my YouTube's doing over there now. Installation. And it goes through both on the Raspberry Pi, Linux, Windows, and Mac. I use the Mac, and it's pretty much spot on. Once you install the software, it's pip install type things. I mean, I'm going to select one of these just so you can get an idea. So making a directory, get clone, creating a Python or a virtual environment for your Python, installing TensorFlow, and then installing the donkey car libraries. When you create the car, it actually takes the template directories and makes a directory for you. In there, there's config.py file. And inside that file, it's got all of your inputs. It's got your PWM signals for your Pi. And so when you go through and calibrate it, you would find out what signals turn left, what signals turn right, and the degrees, and then essentially set it up in that config.py. You also change your throttle in that file. And on these cars, you want to start with about 35% on max throttle, and that's a good start. 25% the car won't move, but 50% you won't be able to control it. It's just way too quick of a car. So that kind of gives you a baseline to start with. Training the data. You want to get about 10,000 images when you're training the data, whether that's driving around a track for about 10 or 15 minutes or using the simulator that I'll show in just a minute. If you want actually a good model that you can actually count on to run a track, you want 30,000 above images. This is the command to create the training data. So it's Python manage drive. -sjs is for your joystick. My favorite's the PlayStation 4 because it's the easiest one to connect to Bluetooth. PlayStation 3 also works. So if you use -sjs, it'll use your joystick that you set up. And the joysticks and instructions are in the documentation really good. So when it's driving, what it does is it creates a picture and a JSON file. And here's an example of that JSON file. So you've got the throttle percentage, that's 40% throttle. Angle 0, so that means I'm not turning, I'm just driving straight. And then you've got the camera image. And so it takes that image and it says, oh, he was turning here. And then it tries to just add all those up and says, oh, well, when the line turns left, I turn left. Okay, I can kind of figure that out. And so it creates a model. Actually, then that's the next step. So actually, you clean the data. So there's a nice little utility, Donkey Tub Clean, and it actually will pull up in kind of a film strip view and let you play through a movie, stop and splice out the parts you don't want, and so that way you can only have the good data in there and do it very quick. You can imagine if you had to open up individually 30,000 images, it might take you a week and a half to actually clean the data, and so you don't. You just let it have all the bad data and you get a bad model. So after that, you build the data, Python manage train, and give it a tub and give it a model. And the train goes into training mode. Tubs is the location of your videos or your pictures and your JSON files. If you're using a simulator, that would be data logs from the training data or from the simulator. And I'll show you that in just a little bit. Specify a model. So here we've got SAINTCON model. And so after you've built that model, and with 30,000 images, it takes about an hour on my MacBook, 2016 model. If you try it on your Pi, take like a week and a half. So I don't recommend doing that, but you could. After you get the model, you copy it back over the Pi, and you run the drive command. So this is driving it and putting it into a model. I want to show you real quick the web interface for that. So this is the web interface that you would get if you were to do the drive without the joystick. And you can see it's just using the camera right off the Pi. And so here we've got a joystick box. I'm unplugged so I can do it. And you could go through and you can see on the left where my steering and throttle angles are changing. And so you could actually train it using this, but it wouldn't be as reliable if you used a joystick. Over here you can actually change what autopilot mode you're in. Here I'm in user. You've got local pilot and local angle. Local pilot is the full autopilot. Local angle means the computer is going to do the steering for you and you're going to control the throttle. My favorite way to run is doing local angle and then up here setting a constant value for throttle and just setting it at 40 or 45% and constant value. There's some benefits of that, but when you really want to train a racetrack or a race car to win the race, this would be a bad way to do it. Because if you use the full pilot, it can actually learn your speed and get faster than you. And so we've seen that several times. But if you use a constant, it's never going to go faster than that. So that's a great example. And you can use it with an iPad or a game controller. Pretty much anything with accelerometer you can connect to the web interface that it's putting out. So it uses Tornado to create a web interface. And that's kind of what it is there. Tomorrow night, we have an event here from 6:30 to 10 downstairs where the workshops are, where we're going to be racing these. We've got, I believe, 6 of them that we will loan out, and we will give you an SD card to go through and program the cars and get running. And the winner of the race will actually receive a donkey car. And so that's tomorrow night. Before that, I want to go through and kind of show the simulator and how it's the same If you don't have a car, you could actually start on this right now and get to know the process. So this is easy to find, both on the docs.donkeycar.com, or you can just Google it. There's several different types here. For the type of races I usually attend and perform, this track is the best. You can see up here we've got several different options. I can't read the options, but one of them is essentially steering it with using the keyboard. One of them is steering it using a pre-programmed path, but then changing the PID values so that it will kind of generate random data to help your model. And then there's a steering with neural network, and that's the choice after you've already built a model. You can fire the model server up on your computer. Once you fire the server up, you could just hit this neural network steering, and your model would actually feed those steering and throttle values straight to your model. I guess it helped if you wanted to see this too. So I've just saved a couple different models based on how I've trained them. And so you can see here that that starts up the server and crashed. Hold on. Okay, so this is one of the things you might come and really run into. And if it's have to activate your virtual environment. All right, so once you see it starting up, you know it's working. You can come back here. And up in the top, you should see inputs. Now, I will warn you, this is kind of an easy simulator run, so it's probably not going to behave very well. The other model might do better. Yeah, so don't. But you can get the idea of exactly how you'd go about doing that. Inside the applications directory on a Mac, or just the directory you run it in on another machine, you can go into show contents. And inside there's this log directory. And when you do the training data and record, it's doing the same exact thing as you would if you were driving around. And so you can see here, and if I scroll to the bottom, it's got the JSON files that match up with it. And so again, you can see that same format that it puts out. And so you can actually get started on all this with just the simulator data. We've got a Slack channel on the SAINTCON channel. Oh, sure. Let's see. So the top one is the SAINTCON Slack channel. We've got a Donkey Car channel on there. And then this one is the main Donkey Car Slack. You can also find it by going to donkeycars.com and clicking on community. You can get access there. Any questions are really quick to answer on both of those, and a couple other links you can't see these right now, so I'll hand them out. But again, tomorrow night, downstairs, 6:30 to 10, self-driving cars, and you can win one. So come see us, and we'll be there to help you get going and everything else. So what questions do we have? Right. What was that? You can. One of the guys went just to the hobby shop, and as long as it's got, I don't know if you can see this, right now the default code works really well with the just the 3-wire ESCs, which is very common in RC. Now, if it's got the integrated board where it's everything on the board and you've got a red and a black wire only coming out, that's a lot harder to do. I'm not saying you can't do it, but it's not like gonna just work out of the box very well. But with these ones, you plug it right into the board on the back. This PWM board is $10, and you plug channel 1, channel 0, and then you just connect it to the Pi, and it's really easy to do it that way. So when I first did my first one, which was this one, it cost me $240, and since then it's been about $180 because the cars have come down a lot. There's a lot of different kind of cars that they already know work. This was the first style. The second style, if you notice, the mounts are a little bit different, and so there's adapters that come with the plans to 3D print, so you can just use the same adapters. The reason why you'd want them the same is if you have the same height on the camera and the same angle from the camera to the ground, if I train on this and I create a model with this, I can hand my model out to anybody else with those same dimensions of the camera and camera angle, and they can come to the track and run without actually doing the data. Or they can take all of my pictures that I've already done and generate their new model. So that's the only reason you'd want a standardized height and dimensions. Other than that, you could use whatever you want, as long as you're not sharing it with the other people. Yeah, really, the Raspberry Pi uses a Raspbian base. There's a Donkey image that already has the source code checked out on it and installed and that kind of stuff. A lot of times the hardest part to get going is getting it configured with wireless. And most of the time it's just making sure that it's talking to 2 different networks so that when one of them's out, you can hit the other one. But it's fun stuff, pretty simple. And other questions? You had one? So these batteries last about 15 minutes if you're full on driving it. The video I was showing right at the very first was a 6-minute video, and we'd done it for about 5 minutes before that. About 11 minutes in, I upped the throttle. So I go from 40 to 45%, and I just start upping the throttle to compensate. And it seems to work out okay that way. But about 15 minutes, you get no power. They do have a lot of other people that have switched out and put parallel 2-cell lipos in, and a lot of just the common Hobby King type stuff. I haven't hacked any of mine apart yet, or made an adapter. But I should, because the ones that come with this, the chargers that come with, it's like you have to charge it for like 10 hours for 15 minutes. And so I need something to hook it up to my speedy charger. But other questions? None? All right. On Twitter, Distracted Dave, feel free to ask me any questions. And I'm also on the SAINTCON Slack. So if you want to get started with the simulator and actually see yourself, creating a model that will ride itself, hit me up on there, and I'll glad to help answer any questions or help you guide you through the process. docs.donkeycar.com has the full write-up of all the different steps for Mac, Linux, Windows. So yeah, thanks guys.